So now I want to talk about velocity versus time graphs. So we've been talking about position versus time graphs and motion maps. And so now I want to talk about velocity versus time graphs. So it's going to be really important that you keep these two things straight in terms of which ones are which, because what works for one does not work for another. And so draw a big line in your notes because now we're going to do velocity versus time graphs. All right, so when we talk about velocity versus time graphs, we are going to be focusing on how fast the object is moving. And what that means is on my velocity versus time graph, all I'm doing is drawing how fast it's going. And now we're going to be dealing with both positive and negative. So just like before, when we had position on the vertical axis, we have velocity on the vertical axis. The units will be meters per second. And on the horizontal axis, we will have time. And that'll be measured in seconds. Alrighty, so if it is stopped, not moving, where would I find a velocity of 0 seconds? Zero on the vertical axis, so you want me to be here? Okay, do I need to stay at 0? So if I keep going, let's say I go like this. Can you tell me, is this 0 velocity? Everybody give me a yes or a no. It's not at 0 anymore, right? Because if I follow this line up and I follow it over, if I put numbers here, this is not 0 anymore. All right, so not that. That's not going to work. So I have to stay at 0 on the horizontal axis in order for my velocity to stay 0. So I'm going to draw a nice big purple line. So the purple one is stopped. So horizontal, flat line. At 0. Okay, so it has to be flat, has to be horizontal, has to be at 0. All three of those have to be true in order for an object to not be moving on a velocity versus time graph. Now, I'm going to draw a few lines. I'm going to draw a red, a blue one, and a green one. Okay, which one of those is going fast, blue or green? Green is going which one? Good, so faster. How do you know? Okay, and how do I know that it's going at a bigger meters per second from looking at the graph? Yes, good. So moving fast, you're further from 0. All right, so then which one is slower? Good. Yeah, so the blue is slow because it's close to the horizontal axis. All right, so then down below, I'm going to draw a pink line. I want you guys to tell me. I'll have two different pink lines down here. Which one of these is going to be slow? The upper pink line or the lower pink line? Everett, Deegan, Adelaide, Ethan, vote. Which one? Upper or lower? Good. All right. So how do you guys know that this upper one is going to be the slow one? Good. Closer to 0. So again, we're keeping with this idea, the one that's close to the horizontal axis is going to be slower. And this makes sense if you think about numbers. So if I put numbers on this axis like 1, 2, 3, 4, and -1, -2, -3, -4, it makes sense that the numbers as you get close to the horizontal axis are smaller. You're going to be going slower. And the farther away you go, the faster you're moving. Okay. And then that would make this one faster. So fast. All right. Going backwards. What is it going to look like when you go backwards? Where is it going to be graphed? How is it going to be graphed? Peter? Good. When it's under the 0. So here, whoa, too big. So here, anything down below the horizontal axis, this is going to be going backwards, because that's where all the negative velocities are. And your negative velocities are going to correspond with going backwards. So below the horizontal axis. All right. Now I want you to think about, what about speeding up? What is speeding up going to look like? Okay. Going up or going down? Okay. So I'm going to draw a few different options, and then I want you to refine what you were thinking, because I want you to think about this, how we defined going slow and going fast. How does that apply to these? Okay, everybody's thinking. I'm giving you a minute to think. All right, good. Now let's talk about these. This first one, are you speeding up? Yeah, good. So you're going from closer to this horizontal axis to farther away. So this one is speeding up. How about this middle, or this middle black line? Oh, so you're saying there's two things happening. Here, I'm getting closer and closer to this horizontal axis. And then up here, I'm getting farther and farther away from it. So that means then that this line both has speeding up and slowing down. So that gets confusing. I'm going to just get rid of that one. All right, how about this black line at the bottom? Speeding up or slowing down? Good, slowing down. How do you know it's slowing down? Okay, good. So you're getting, so for speeding up, we're going to kind of define these generally. Speeding up is when you get farther from the horizontal axis. And slowing down is when you get closer to the horizontal axis. All right, so I'm going to draw a couple more lines on here then. I'm going to draw one this way. I'm going to draw one this way. All right, the top brown line. This is turning into chaos over here. All right, top brown line. Speeding up or slowing down? Good, I like how you're pointing. That's good. Speeding up or slowing down? Awesome, good. Slowing down. Because you're going from a big number, and as you're getting closer to the horizontal axis, you are slowing down. Good. All right, this one is also going down. This brown line here. It's also going down, but are you speeding up or slowing down? Speeding up, slowing down. Good, you're speeding up. All right, so when we're talking about velocity versus time graphs, just like the slope on a position versus time graph is velocity, the slope on a velocity versus time graph is acceleration. So I'm going to write that over here. So slope on velocity versus time graph is acceleration. Cool. So if I'm saying that the slope on a velocity versus time graph is acceleration, then I should be able to go through here and mark if it's a positive or a negative acceleration. And this is where it gets weird. All right, so the first black one that is speeding up, is that a positive or negative acceleration? Positive or negative? Positive or negative acceleration? Positive or negative acceleration? Let's go. All right. Positive acceleration, good, because it's going up, right? You've got a positive slope, it's going up. So you've got a positive acceleration. All right, what about this one here slowing down? The first brown one slowing down. I've got 2 negatives, 3 negatives, 4 negatives. There we go. Good. So it's a negative acceleration because it's going down. So it's only about the slope. All right, speeding up. This one down here, the brown one in the bottoms. Positive or negative acceleration. It is speeding up. So it is a positive or negative. We have a discrepancy. We've got about half of us saying positive slope because it's speeding up. We have the other half of us saying it's a negative acceleration because it has a negative slope. Okay, what is our acceleration? Slope on a velocity versus time graph is acceleration. Okay, so now thinking about it, ignore the speeding up part. Is it a positive, negative, or zero slope? Okay, hold on. We're going to take a pause here. All right, we need to know what's a positive, negative, and zero slope because I have some looks like, I don't know. Okay, positive slope goes uphill. It can be down there or up here. These are both positive slopes. Negative slopes go downhill. They can be anywhere. All those are negative slopes. A zero slope is the ones that are flat. And now this looks like a ginormous mess. All right, are we good? So positive goes up, negative goes down, and 0 is flat. So now we need to look at this one. Is that brown one going up or down? Down. It's going down. So this is positive, negative, or 0 acceleration. Yes. Good. Negative acceleration. And then last but not least, we have this slowing down black line. Slowing down black line. Is it positive, negative, or 0 slope? Yes. Yes. Good. All right. So we've got a positive acceleration on this one. Whew. That was really hard. You guys look tired. Okay. So we have a lot of notes on a small little diagram. So how do you know where the object is? Is there any way of knowing? This is my favorite example. I just drove 65 miles an hour for 2 hours. Where am I? Where did I start? Can you tell me? Just by knowing how fast I was going and how long I was driving, there is no way to know where I'm driving. Okay, so you cannot know where an object is from a velocity versus time graph. So you don't know. How do you know how far the object traveled between 0 and 4 seconds? Well, that is the next thing that we need to learn. All right, so last but not least, down here, we are going to do a velocity versus time graph. Okay, I'm just going to do positive for the moment. If I had a velocity versus time graph that looked like this, oops, like this, let's say it was going 3 meters per second for some number of seconds, you'll notice that the area under this, if I tried to find the area underneath this graph, the area of a rectangle is base times height, or length times width. Well, in that case, my units for this side are meters per second. And my side on this side, my units are seconds. So I've got meters per second times seconds, which will give me units of meters. And then that cancels out. What do meters measure? Distance. Cool. So I could take a velocity versus time graph then, and if I know the area of this, that is going to be how far I went. So that is my distance traveled. Okay, well, I don't always travel at a constant speed. So maybe instead I speed up the whole time. Like that. Well, how do I find that area now? Good. So you know in your brain that the area of a triangle is 1/2 times base times height. which is the same thing as base times height divided by 2. It doesn't matter which way you do it. You get the same answer. Good. So then I could figure out that. Well, then there's one more. Maybe I have a trapezoid. Well, if I have a trapezoid, let's say I already started with some starting velocity. And I want to figure out this area. Well, that looks really scary now if you look at it as one big triangle, but it's not so bad if you break that trapezoid into two shapes and you realize that it really is just a triangle plus a rectangle. And if you add the two together, you'll get the total area of your trapezoid. And if you want to use the trapezoid area equation, that is also totally fine. But I like thinking of it as a triangle plus a rectangle. And then I think that makes it much easier. All right, any questions? Okay, so I'm going to explain to you what is expected in terms of your distance learning, and then we'll go from there. So for distance learning, there are 4 problems down here. 1, 2, 3, and 4. You are going to do these 4 problems. And then in your Google Classroom, there is a second worksheet that looks like this. And you're going to do this one as well. Okay. The easiest way to do this one is you can look at where these are and you're going to create a motion map for this one. So the easiest thing to do is t times 0 is at 0. So I'm going to put a dot there. And then at 1 second, I can look at where it is and put a dot there. And at 2 seconds, I can follow it up and put a dot where it is. And every second, I will put a dot on my motion map. And then once I have all the dots drawn, I can connect them with my arrows. All right. And then the next one, you're taking a motion map and you're going to create a position versus time graph. For this one, I highly recommend going through and labeling these T0, T1, T2, T3, T4, T5, because that way when you go to graph it, you don't mess up. Okay. And then there's a couple other questions on here that I want you guys to think about. And then that's it. So for distance learning, you've got the one that we worked on today, finishing the last 4 problems on that, and then doing this worksheet. And if there is anything that you did not finish that I had assigned originally to have due today, but you missed that memo, you'll have until Friday to get it done. If you need more time, please reach out and let me know. Are we good? Okay.